All right, let's kick things off with a question I bet you've never thought about. What in the world does a simple thermostat have in common with a self-driving car? It sounds like the start of a bad joke, I know, but it's not. Today, we're going on a journey from the simplest devices in your home to the most complex AI on the planet to uncover the secret that connects them all. So let's really think about this puzzle for a second. A thermostat and a self-driving car. I mean, on the surface, they're just worlds apart, right? One is this tiny, simple switch on your wall. The other is, a mind-bending piece of modern engineering. But at their absolute core, they actually share the exact same fundamental design. And the big secret is this. They are both what we call intelligent agents. So today, we're going to climb the ladder of AI intelligence, starting from the absolute basics and going all the way to the cutting edge. This right here is our roadmap for the journey. Okay, so first things first. Before we can climb that ladder, we need to build a solid foundation. Let's get really clear on what we actually mean when we talk about an AI agent. It's a term that gets thrown around a lot, but its meaning is actually super precise. And here it is, the big definition. It's actually pretty simple. An agent is just anything that can sense the world around it and then do something about it. Think about it. Your eyes are sensors, your hands are actuators. For an AI, a camera is a sensor and a motor is an actuator. It's all about that simple connection. Sense and then act. And this connection isn't just a one-time thing. It happens in this constant, never-ending loop. The agent perceives the world, right? It gathers data. Then it has to reason about that data based on its programming. And finally, it acts. It makes a decision and changes something. Then the whole cycle just starts right over again. It's constantly perceiving, reasoning, and acting. So if you wanted to build an AI agent, what's the recipe? Well, it all starts with this simple but really powerful checklist called the PSAS framework. Before a designer writes a single line of code, they have to answer 4 key questions. How do we measure success? Where is this thing going to operate? What can it physically do? And what can it see? And this table right here just brings the whole PEACE framework to life. Look how it applies to both a super simple thermostat and a more complex robot vacuum. For the thermostat, performance is just maintaining the temperature. It senses with a thermometer and acts with a heater switch. Simple. For the vacuum, performance is cleanliness. It senses dirt and acts with its wheels and brushes. See, it's the exact same fundamental design, just with different parts. All right, now that we have the blueprint, it's time to climb that first rung on our ladder of intelligence. Let's talk about the reflex agent. This is AI in its most basic, most raw form. But hey, don't let its simplicity fool you. It is incredibly powerful. The logic for a reflex agent is just beautifully simple. It all comes down to one single rule. If my sensor detects this condition, then my actuator does this action. That's it. There's no memory of what happened 5 seconds ago, and there's absolutely no planning for the future. It's pure, unfiltered reaction to the here and now. Now, this design has some pretty clear trade-offs. On one hand, because they're so simple, they are lightning fast. But the flip side is that they're totally stateless. They have zero memory, which means they can't learn from their mistakes. Imagine a robot vacuum that just keeps cleaning the same clean spot over and over and over again because it has no idea it was just there. That's the big downside of a reflex agent. This is my absolute favorite way to think about a reflex agent. Just picture a moth drawn to a flame. It sees the light, and its internal programming just screams, fly towards it. There's no thinking, no remembering the last time it got a little singed. It's just a pure, hard-coded reflex. And that's exactly how our simplest AI agents work. So yeah, reflex agents are fast, they're efficient for simple stuff. But that lack of memory, that's their Achilles heel. They're great for a task where you don't need context. But what happens when an agent actually needs to understand the bigger picture or, plan ahead? Well, to answer that, we've got to climb to the next level. And welcome to level 2, the planning agent. This is a huge leap because this is where AI stops just reacting to the present and actually starts thinking about the future. Unlike those reflex agents, planning agents can deliberate, they can weigh different options, and they can choose what they think is the best path forward. And within this level, you've got 2 main types. First, there's the goal-based agent. This one's like a maze solver. Its only focus is, did I reach the end? Any path that gets it there is a win. But then you have the utility-based agent. This one's a lot smarter. It asks, okay, but what's the best way to get there? It's like a savvy taxi driver who's always weighing the trade-offs, speed versus traffic versus safety, to give you the absolute best ride. This table is a fantastic summary of how far we've come. We started with the super simple rule lookup of a reflex agent. Then we moved up to search and planning with goal-based agents. And now, with utility-based agents, we've introduced this new idea of optimization. We're not just asking, did we succeed anymore? Now we're asking, how well did we succeed? And that is a huge step in the evolution of AI. So, up until now, all the agents we've talked about are programmed with a fixed set of rules. But what if an agent could learn and adapt all on its own? Well, welcome to level 3, the learning agent. And this, my friends, is where AI starts to get really, really interesting. The secret sauce here is a technique called reinforcement learning. And honestly, it's a lot like training a dog. You don't hand your puppy a rule book, right? No. You reward it when it does something good, and you just don't when it does something bad. And over time, the dog just figures it out. AI agents do the exact same thing. They learn through trial and error, slowly but surely figuring out what actions lead to good outcomes. And this whole learning thing happens in a constant loop. The agent observes the world, it tries an action, and then the environment gives it feedback, either a reward or a punishment. Based on that feedback, the agent updates its strategy, making it a little more likely to do the good stuff again and a little less likely to do the bad stuff. Observe, act, get feedback, update the plan, over and over and over. Just think of an AI learning to play a video game. The first time it tries, it's a total disaster. It walks right into the first enemy, right? But after thousands and thousands of games, getting points as rewards and losing lives as punishments, it totally masters the level. This is exactly what happened with systems like AlphaGo. It became a world champion by just playing against itself millions of times. But these learning agents face a really deep, fundamental dilemma. Should they exploit what they already know works, or should they explore new, risky possibilities? It's like choosing between going to your favorite restaurant that you know is great, or trying that brand new place down the street that might be amazing, or it might be terrible. For AI agents, and even in business with stuff like A/B testing a website, this is a constant, difficult balancing act. And that brings us to the very top of our ladder, the new frontier of AI, LLM agents. These are the autonomous agents you're hearing about in the news right now, and they are powered by the exact same tech behind things like ChatGPT. The huge game changer here is that these new agents use large language models as their brain. Think of it this way. If a reflex agent is a knee-jerk reaction and a planning agent is a chess player, an LLM agent is like a creative problem solver. It can use its massive understanding of the world to come up with totally new solutions to really complex problems. A perfect example is AutoGPT, a system that can take a huge goal like start a new online business and actually break it down into actionable steps. So here's how it actually works. You, the user, give the agent some big high-level goal, like plan my vacation to Italy. The LLM brain then breaks that down into smaller tasks. Find flights, look for hotels, check reviews. Then, it uses tools like a web browser or a code interpreter to actually get those tasks done. But the most crucial part is that fourth step, reflection. After every single action, it stops and asks itself, did that work? Am I closer to my goal? And what should I do next? That ability to self-critique and adjust its own plan on the fly is what makes these agents so incredibly powerful. And this all leads us to our final and maybe the most important question of all. As these agents go from being simple tools to truly autonomous partners that can reason and plan for themselves, a massive new challenge appears. How do we make sure their decision-making process stays robust, predictable, and fully aligned with the original goals we gave them? Because solving that technical problem, well, that's going to define the entire next chapter in our relationship with artificial intelligence.